Here's a better comparison of how of two tests that are much more similar. And you can see when you're running similar tests, it's very easy to spot differences, how useful this is. And here it says a simulated ET in mile an hour. Um, you can see that this is way wrong. That, I mean, this thing is a 3,000-pound car on a 10-horse motor, so it's not real. It has no speedster here, but you can see that here's the average horsepower for the two runs, and here's the difference, and here would show the ET difference here. So this shows you a better idea of how that comparison feature works, and that is available in preferences. What I'd also like to show you is if you go into your current reading screen, there's a lot of options here. Trace recorder is kind of handy. Um, what's on these gauges here is handy. These exhaust thermocouples in the DataMite specs. And I'll show you how this works. If you go down here into the thermocouple channels, and okay, our master is a little bit different than which it said. We have an exhaust thermocouple number 1 here. I'm going to save this as the master. And then you're going to see this exhaust thermocouple. Whatever you got set as exhaust thermocouples here, these will show up in the graphs on the current reading screen. So if we go over here, when it starts communicating, oh, it's not communicating. It wasn't communicating because it had the wrong COM port set. But you can see here, 74 degrees is now showing up over here on exhaust thermocouples. And as that temperature goes up, you can see it's going up over on that screen. Now, obviously 85 is pretty cool for exhaust thermocouple. Other things you can set here is update rate. Most computers nowadays can handle 10 per second. If you had a really old computer, you might have to drop that to a lower rate. Gauge settings, this is the 2 round gauges up here at top. And you can pick what channel do you want to show on them. Engine RPM, dyno RPM, and what settings. Maybe since you saw us topping out there, maybe what we should do is set this more to 0 to 2400 RPM, and this one here maybe 0 to 6000 RPM, so that we wouldn't top them out. Another thing you can do here is this very first choice, well, I'm sorry, this very first choice is user specified. And here you could specify any max and minimum you'd want on the gauge. So let's say we know exactly what range we're going in, and we don't necessarily want to see 0. So let's say we want to go, I want to be able to see 6,000, and I don't care about anything below 3,000. Now sometimes this won't refresh right away, and if you back out and go back in, you'll see that now we got 3,000 to 6,000 RPM here. And as soon as we start establishing communications, we'll turn our engine on. And you can see nothing's happening until the dyno gets to 3,000. Just like it should. You got your bar graph settings here. This is these two horizontal gauges here. And what can we put on them? Let's put, let's see what we got here. Let's put head temp on there. And 0 to 240 head temp. Let's say no, we need that. Yeah, let's go with that for now. We could be user specified if we wanted to. And even though exhaust temp is 0, let's put exhaust temp, or let's put power volts on there, or let's put humidity on there. 0 to 120. And you see we got head temp and humidity there now. We're going to establish communications. And there you can see our humidity. And if I breathe on the humidity, you can see how it spikes up. And head temp here, when the engine starts warming up, you can see it starts to go up. Now, sometimes you'd like to have something flagged out at you if something goes wrong, like you maybe want head temp if it's over 300 degrees to flash red at you. What you do then is you click on options, and here's your exhaust temp scale, which would define this over here, Color warning settings. Adjust the color warning settings, or you could turn them all off. But let's say you want to adjust it. And the channel we want to use is head temp. We talked about that, head temp. Use color warnings, yes. We want to caution if it's greater than 270. And a warning, that means it'll turn yellow. And a warning if it's greater than 300. Okay, keep the changes. Yep, I want to keep them. Now let's see what happens. We got them down here. I'm going to close this out just to make sure. Sometimes you got to do that to refresh all the settings, especially on the current reading screen, because it gets so busy doing everything else there. So let's see what happens now as our head temp goes up in temperature. Okay, we're going to have this go up. Oop, there it went to yellow. And when it goes over 300, it went to red. So, and you can select whatever channels you want to do this. Other things, analog filtering, that's determines how much jumpiness you're going to allow in the data. The more filtering, the slower responding, but the more smooth the readings, the less filtering, the more it'll jump around. So anyway, that's your trade-off. Another very popular or powerful feature is this trace recorder. Click on trace recorder here, and it'll show you what do you want on the trace recorder. And you could say engine RPM and dyno RPM, okay? 0 to 6,000 for both. So that's what we're going to put on the trace recorder. The trace recorder speed. And we want 15 seconds for every section. I believe there's 3 sections to it. You can, if you made with more time, you'd have a slower trace recorder. And then we can show the trace recorder. And again, a lot of this has to do with because we're doing a movie file at the same time we're doing fairly fast communications here. Things get a little slow. And I'm going to back out and again go back in. And here's your trace recorder. And again, because we're doing a movie, which takes a lot of computer speed, this thing may not work as well as I had hoped. But here you go. Here's trace recorder speed. And you can see this is a very nice way to track what's going on. And if that's too fast for you, you could slow it down. But let's say if you were tracking air-fuel ratio or exhaust temp while you made changes. This would be a very nice way of tracking if those changes are having any effect. Like I said, very powerful feature called trace recorder. And we can turn that off if you want and go back to the standard. But again, you may have to get out of this screen. Well, no, it recovered. But anyway, those are some of the powerful features you can do in this current reading screen. Now, when you are troubleshooting, and this is what I'll always do on the phone with people, these numbers down here are the numbers you can trust. I don't trust, you can trust the numbers up here, but I can't always trust that you've set things up right, that they've been set up right. So don't assume if this says engine RPM up here and you're not seeing anything and it seems wrong, that it's wrong. Look down here in the engine RPM down here and see what that's reading. If this is reading correct and this is wrong, you may have a gauge setting here that isn't correct. Now, what I'd like to show you is a little bit of explanation about this master DataMite and master Dyno settings. What I'm going to do is I'm going to pull out of the library something that is a very different type of test. I'm going to pull out this something that was done with a DataMite 2. Okay, and you can see here's the DataMite 2 making up around 250 horse, 300 foot-pounds, and here's our little 10 horse Briggs or whatever it was down here for comparison. This is what's on the main screen now, and you can see it's a V8, DataMite 2 and such. If we now go to start a Dyno pull, it's not going to use the DataMite specs and Dyno specs from that V8 test. it's going to use our settings for the master dyno and master DataMite specs. You can see here they are, and if we go and make a pull on this, let's get our dyno RPM drop way down here, and we make a pull, like that. Now we're going back down, and we press F2 to stop the pull. If you want to save it, I'm going to say no just to illustrate the point here. It went back to our original settings that are in the master, and that's why it makes the master DataMite and master dyno settings so useful. The test that's on the main screen right now is a DataMite 2 on a V8. This says DataMite 3 is what we're using for our DataMite, and our dyno is an inertia dyno with that much inertia. And this one here was done with a water break. So you can see that even though we had on the main screen a totally different DataMite and dyno setup, it knows based on the master what it's supposed to be. Now the engine specs are going to be carried over from this thing. The test conditions are going to be carried over from this test. And you can see the comments here would be carried over if I kept them, but I can just blank them out, or I can just change them like that. I don't know if you know what I'm doing here. I'm clicking, I am dragging, holding the mouse button down and dragging through that to highlight everything. And if I go delete, I've deleted all that stuff. You can also just press the delete key, or if you're on the other end of it, you can press, this is the backspace key that lets you delete things. So anyway, but I just wanted to illustrate how important it is, what the difference is to the master DataMite and master dyno specs. How having those masters keeps you from screwing things up when you go to make a new test. So let's get this data. And this is some, like I said, this is some garbage data. But, and if you look in the engine specs here, you can see this is a V8, 8 cylinders, bore stroke and such, our Rover V8. So anyway, and you can see the huge change in power and stuff here.